Thanks for sticking around. My name is Kingsley Imufua, your host. Welcome to episode 6. In series 1, Iron Gate required 312 CFA piles to a depth of 9.5 meters. FULCRUM is on a completely different scale, requiring more than 1,200 piles. These are distributed across a massive 25-hectare campus, carrying 3-story precast structures, 60-ton transformers, and 40 generators, each weighing 30 tons. Getting the foundations wrong at FULCRUM doesn't just affect a corner of the building, it affects the structural integrity and the entire program of the campus. A 25-hectare site requires a geotechnical investigation that goes far beyond Series 1. We leave no stone unturned in our ground engineering. The FULCRUM ground investigation program included 48 boreholes, drilled to depths of up to 25 meters to map the underlying strata. We also conducted 32 trial pits and cone penetration testing at 15 critical locations to assess ground resistance and strength. Our team performed laboratory testing on 280 soil samples and conducted a specialist groundwater study to ensure we understand every variable. The investigation found made ground to 3.5 meters depth. Because of its variable composition, all piles must be socketed securely below this layer. Between 12 and 22 meters, we identified a layer of stiff clay. This higher capacity bearing stratum is where we seat our heavily loaded positions. Below 22 meters, we found weak rock, specifically mudstone. This is used for our highest load positions, including the generator yard raft foundation. Groundwater at 4.5 meters required dewatering for all deep excavations. This finding updated our temporary works and construction safety specifications. In the southwest corner, we discovered historical diesel contamination from a former vehicle maintenance depot, a detail not found in our initial desk study. The resulting remediation program, involving soil washing and bioremediation, added 12 weeks to our enabling works in that specific zone. Now, let's dive into the specifics of the piling strategy. We deployed different pile types across the campus based on the local structural demand. For the data hall structural columns, we use CFA piles, continuous flight auger, to a depth of 13 meters. These provide moderate loads with low vibration. The transformer bays carry 40 tons each. For these, we use driven precast piles, which offer the high point load capacity required for such heavy equipment. At the generator yard, where 20 massive units sit, we use a massive combined raft foundation supported by a dense grid of driven precast piles. The BSP substation compound uses large diameter CFA piles to handle the 60 megavolt ampere transformers, the highest single point loads on the campus. For non-critical areas like roads and hard standing, we use vibro-compaction ground improvement. It's a cost-effective alternative to piling for lighter loads. The cooling tower compound also uses CFA piles. Here, we add vibration isolation pads above the pile caps to dampen the dynamic load of the rotating equipment. Pile groups are necessary when the load from a single column or piece of heavy plant is too great for any single pile to support safely. In these groups, multiple piles are connected by a reinforced concrete pile cap. This critical element distributes the massive load across every pile in the cluster. Instead of individual groups for each generator, FULCRUM uses a single combined raft foundation, approximately 80 meters long by 30 meters wide. This 1 meter thick reinforced concrete raft sits on 160 driven precast piles. This group design effectively eliminates the risk of differential settlement. Differential settlement, the difference in level between adjacent parts of the structure, is the most critical design criterion for data center ground engineering. Even 20 millimeters of difference between columns can cause raised floor misalignment, damage busbar connections, and disrupt cooling unit precision. FULCRUM's foundation specification is strict, limiting differential settlement to just 10 millimeters across any 6-meter span of the building. To ensure we stay within these limits, We installed a settlement monitoring array consisting of 120 points embedded in pile caps and slabs. These monitoring points are leveled monthly using precise optical surveying equipment and total stations to track ground movement with millimeter accuracy. This data is constantly compared against the predictions from our geotechnical model. Any deviation triggers an immediate review by the structural engineering team. On FULCRUM, all monitoring results remained within design predictions throughout the build, a direct result of our comprehensive Phase 2 investigation, series signal. Ground investigation is not a box-ticking exercise. It is a critical risk management strategy for the entire Hyperscale program. The southwest contamination added 12 weeks. If we hadn't found it until piling started, the impact would have been catastrophic. Invest in your ground. Next time we enter the heart of campus power, the substation. 132 kV GIS switchgear, SF6 free technology, and the 11 kV distribution ring. Thanks for sticking around. Please subscribe, like, and share to follow FULCRUM's progress. We value your comments and questions below. My name is Kingsley Amafua, signing off. Let's keep building the machine. I'll see you in the next episode of Catalyst Grid.